Hi everyone, this is Samit Sankanavar. I welcome you all back to my channel. In this session, we are going to have a detailed revision of another important chapter from class 10 mathematics, that is coordinate geometry. Before I start with the actual presentation, let me first brief you about the contents of today's presentation. First, it is going to be introduction to the coordinate geometry. Then we are going to have a look at some of the important terminology used in this chapter. Next, I will explain about distance formula. Then we are going to see section formula. After that, area of triangle using coordinate geometry. Then some of the related examples. It becomes very difficult to understand this chapter if we don't have a clear picture of these two terms, that are ordinate and coordinate. So let me try to explain you these two terms one by one. First of all, ordinate is a term used to locate an object or a point with respect to a fixed position in one dimension. Suppose A is a fixed point and B is an arbitrary point. An arbitrary point is a point that can change its position anywhere. Suppose I want to keep my B point here, here, anywhere, whereas I'm going to keep A point as fixed position. So whenever I move this point B, so I can keep my point B here, or I can keep it here or here, anywhere. Then distance of that point B from any fixed point. In our case, this is point A. So that distance is considered as ordinate of that arbitrary point. If I want to put it in a line, that statement, that is location of point B from A is 2 km. Here ordinate of B with respect to A is 2 km. Remember, location of 2 points when we consider in one dimension, it always represents the straight line distance between those 2 points. You can see here B point is here and A point is here. When I connect these 2 points, it always forms a straight line. So whenever we talk about ordinate, this is always the straight line distance between those 2 points. Now, if you have understood the term ordinate, let us move on to understand the second term, that is coordinate. Basically, coordinate is a pair of ordinates and it is a term used to locate an object or a point with respect to a fixed position in two dimension. If I try to explain you this with an example here, in the previous example, we considered only one point, that is point B, and location of that point B with respect to a fixed point A was just called as ordinate. Now, in order to locate point C from A, we can consider that distance of point C from A is 2 meter in horizontal direction and 3 meter in vertical direction. These 2 meter and 3 meter are nothing but ordinate of point B and ordinate of point C with respect to point A and B respectively. Therefore, if I want to explain or express location of point C directly with respect to point A, then I need to make use of these two ordinates. Therefore, pair of these two ordinates is called as coordinate. I can say coordinates of C with respect to A are 2 meter and 3 meter. Always remember, coordinate we always represent first in X direction, then in Y direction. Means coordinate of C would be 2 comma 3. Therefore, we have to travel 2 meter from A, then go up by 3 meter in order to reach point C. Here A is our reference point and we are locating the address of point C with respect to point A. In my previous slide, I used words called as horizontal distance of a point and vertical distance of a point. Mathematically, those 2 points are represented as x-axis and y-axis. Remember, value of x and y-axis corresponding to a particular point are called as coordinate of that point. It is nothing but ordinate of that point in x direction and ordinate of that point in y direction. When we consider those two ordinates, that makes a pair. Therefore, they are called as coordinate of that point. Suppose I want to explain you that with an example here. This is suppose point C. You can see this horizontal line. Always wherever this vertical and horizontal line meet, this is called as origin. We represent it as 0 or also sometimes as O. Remember, this horizontal distance, this is called as x-axis, and this vertical distance, this is called as y-axis. Now, if I want to locate point C somewhere on this plane, I can keep it here, 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 anywhere. Suppose I consider a point C here. Now, location of this point C with respect to this origin is 2 units in x direction and 3 units in y direction. Therefore, coordinate of this point would be C 2, 3, where 2 is nothing but x ordinate and y is 3 is nothing but y ordinate. When those two ordinates make a pair, they are called as coordinates. Remember, these coordinates are represented generally as C x, y. Means first always we write x ordinate, then we write y ordinate of that point with respect to a fixed position. Now let us understand some of the important terminologies used in this chapter. First of all, the distance of a point from the y-axis is called its x-coordinate or abscissa. In the previous example, we have seen how we represent coordinates of any point. Then suppose this is a point A, which is present at this location. Now if I want to understand how far it is from y-axis, that is nothing but its x coordinate. If I count x coordinate here, it is 1 and 2 units. Therefore its distance of point A from y-axis is nothing but 2 units. Remember, coordinates of a point on the x-axis are always of the form x, 0. If any point that falls on this x-axis, then its y-coordinate will always be 0, because value of y-coordinate starts from here, that is 0, 1, 2, 3. If any point that falls on this axis, its y-coordinate will always be 0, and value of x will just give the location of this point. Similarly, distance of a point from the x-axis is called its y-coordinate or just ordinate. If I want to explain you this with an example, suppose now I consider a point A here. Now if I want to measure distance of this point A from x-axis, this is our x-axis. Now distance of this point A from x-axis is nothing but 3 units. Therefore, I can say y coordinate or just ordinate of this point A is nothing but 3 units. Similarly, remember one more point, that is coordinate of a point on the y-axis are of the form 0, y. We have seen in the previous slide that always we represent first x then y, that is a coordinate of any point as x, y. Therefore if a point is present exactly on the y-axis, then its x coordinate is 0, because x starts on this side, that is positive 1 2 3, then negative 1 2 3 here. And if any point is present exactly on y-axis, then it is exactly at the 0 location for x-axis, then some distance for y-axis. Therefore it is always 0, y. Now let us go to the third subtopic of this chapter, that is distance formula. Here one question arises, why do we need to study this distance formula? Let me try to explain you this with an example in a very simple manner. First of all, you are given with a point, suppose point A, and they are telling that coordinate of this point is 2, 2. That is, its x distance is 2, and from there its y distance is again 2 units. Similarly, another point is given to you, that is point B, whose coordinates are 4, 3, something like this. Now if I tell you to measure distance of this point A from origin is nothing but its coordinates are 0, 0. Suppose this point A is present at this location, wherever y is present, which means its x coordinate is 2 and y coordinate is also 2. Now if I ask you to calculate distance of this point from origin, that will be the straight line distance. You can apply Pythagoras theorem and find this. That we already know. How do we do that? Square root of 2 square plus 2 square, that is 4 plus 4, that is 4, 2 times 4. If I take 2 outside, that will be 2 root 2. Therefore distance of point A from origin is 2 root 2. Similarly, distance of point B from origin we can easily find out, that it is x coordinate is 4 and y coordinate is 3. Therefore this distance would be 4 square plus square root of 4 square plus 3 square. That would give me answer as 5 units. But What is the distance between A and B? If we want to find the distance between any 2 points whose coordinates are given, in that case, this distance formula is going to be very useful. That is also derived on similar concept that we just calculated now in order to find distance of any point from origin. Let us see how we can uh, derive this formula, that is distance formula. Let us understand what is the distance formula and how it has been derived. And using that formula, how we can find the distance between 2 points when its coordinates are given. Suppose I consider a point A on this plane somewhere here, and its coordinates we can clearly see that 2 comma 2, that is x is 2 and y is also 2. I'll represent this as x1 y1. Similarly, I'll consider one more point, that is point P somewhere here, and its coordinates I will assign it as x2 y2 and its coordinates are 4 comma 3. Now I'll take one more point, that is point C, that is somewhere here. Now, if I want to find the coordinate of this point, that would be 4, comma 2. That is x is 4, y is 2. If you carefully observe that this 4 is nothing but this x2 and this 2 is nothing but this y1. Means whatever y coordinate of this point A, this same y coordinate is shared by this C point, and whatever x coordinate this B point is having, that is 4, same x coordinate is shared by this point C. Therefore this 4 comma 2 is nothing but x2 comma y1. Therefore I have taken x2 from here, that is 4, y1 from here, that is 2. Therefore coordinate of point C, we can clearly see it as 4 comma 2. Now AC distance here is nothing but OC distance, that is distance x ordinate of point C minus x ordinate of point A, that is nothing but OC minus OA. That will give me x2 minus x1, that is nothing but 4 comma 2, that is 4 minus 2, that is 2. Similarly, BC distance, this distance if you can see, that is nothing but this y2, that is coordinate y2 minus this is y1, y2 minus y1, that is nothing but 3 minus 2 is equal to 1 here. Now you can see it has formed a right angle triangle here. Now using Pythagoras theorem we can find this distance AB, that is AB is equal to square root of AC square plus BC square. AC is nothing but x2 minus x1 and its square is x2 minus x1 whole square plus BC square. BC is nothing but y2 minus y1 and its square is y2 minus y1 whole square. Therefore, distance formula for any 2 points whose coordinates are given can be considered as AB is equal to under square root x2 minus x1 whole square plus y2 minus y1 whole square. One important remark that we can consider from the distance formula is distance of a point P x comma y, any point P x comma y from the origin, that is whose a point whose coordinate is 0 comma 0 is given by OP, that is point O is origin, point P is any point that we have considered in xy plane, is nothing but square root of x square plus y square, where x comma x and y are coordinates of that any arbitrary point that we are going to consider. Let us try to understand this with an example here. AB is equal to square root of x1 minus x2 whole square plus y1 minus y2 whole square. This we have just now seen in the previous slide. Suppose I consider any point A and I want to know its distance from origin, that is shortest possible distance, that is nothing but this distance. Here I can directly consider it as OA is equal to, in place of x1 I'll put it as 0 because coordinate of this point is x coordinate of this point is 0, and x2, that is x coordinate of point A, that is nothing but 2 here. You can see that x coordinate of point A is 2 here, that is 0 minus 2 whole square plus y minus y2 whole square. Y coordinate of this point is again 0. I'll substitute it as 0 minus y2 means y coordinate of this point A, that is 2 units minus 2 and whole square. Here you can see 0 minus 2 is minus 2 and its square is 4 plus this is also 4. Therefore, distance OA is equal to 2 root 2, that we have directly calculated using this formula, indirectly using this formula, because this anyway this term and this term is going to be equal to 0, so only one term would be remaining here, that is nothing but x and y coordinate of point P, where whose distance we want to calculate from the origin. Now let us take some examples on the distance formula and try to understand them. Example 1, find the distance between the following pair of points. So these are the pair of points that are given and we want to find distance between these 2 points. Now I'll consider my first point as point A and whose coordinates are taken as 2, 3. I'll assign them as x1, y1. Similarly, I'll consider point B as 4, 1 whose coordinates are x2, y2. Distance between the points A and B is given by, we know the distance formula, AB is equal to under square root x2 minus x1 whole square plus y2 minus y1 whole square. If I substitute all the values here, x2 is nothing but 4, you can put it here, x1 is nothing but 2, I will put it here, y2 is 1 and y1 is 3. When I substitute all the values and try to simplify this, first I'll keep under square root as it is, 4 minus 2 is 2, 2 square I'll keep as it is, plus 1 minus 3 is minus 2 and its square. Now 2 square is 4 and minus 2 its square is again plus 4. Therefore distance AB is equal to under square root 4 plus 4, that is nothing but 2 times of 4. If I take square root of 4, that will come out as 2 and inside root 2 will be remaining. Therefore distance AB of these two point, if I consider first one as point A and second one as point B, is nothing but 2 root 2 units. Second example is point A is given as minus 5, 7. I'll take it as x1, y1. Point B is given as minus 1, 3. I'll take it as x2, y2. Applying the distance formula again and substituting all the values in this, x2 is minus 1, x1 is minus 5 and y2 is 3, y1 is 7. Remember x2 I'll take it as minus 1 and this minus I am keeping it as it is here, and x1 of minus 5 for x1 I am going to keep it in the bracket here, and when I open this bracket it is minus 1 minus of minus plus 5 whole square plus 3 minus 4 3 minus 7 is minus 4 its square. When I do this calculation I'll be getting AB as 16 plus 16, that is 2 times of 16. When I take square root of 16, that is 4, and inside root it will be 2. Therefore distance AB for these two pair of coordinates is nothing but 4 root 2. Next subtopic of this chapter is section formula. Let us try to understand this one. First of all, what is the section formula? Suppose we have a straight line here whose coordinates are AB is our straight line whose coordinates are x1, y1 and coordinate of B are x2, y2, and there is another point P somewhere on this line. Suppose it can be here, it can be here, it can be here. Now I want to know this point P is dividing this AB in what proportion. If I keep it exactly here, that would somewhat be like it is dividing point straight line AB exactly as half, that is 50% is on this side and 50% is on that side. So I want to know the coordinate of that point which will divide straight line AB in a certain proportion M1 and M2. Maybe this is 20%, this is 80%, 60, 40%. Likewise, whatever proportion I want to divide any straight line, where should I keep that point, that arbitrary point? So that will create particular section inside this straight line. Therefore, in order to calculate coordinate of that point, this section formula has been derived. Let us understand that as if A and B are 2 points on a straight line and P is another point on the same straight line, positioned in such a way that it divides the distance between AB in M1 is to N2 M2 ratio respectively. So this point P is dividing this straight line AB in M1 is to M2 ratio. Therefore, I want to know the coordinates of this point P. When coordinates of point A and B are given, to find out the coordinates of point P, this section formula can be used. Therefore, section formula is given by p x comma y, that is coordinate of point P here, is given by m1 into x2 plus m2 into x1 divided by m1 plus m2, then m1 into y2 plus m2 y1 divided by m1 plus m2. m1 plus m2 is nothing but section in which this point is dividing this, that is always be going to equal to the proportion, sum of the proportion that this point is going to divide this straight line. Then this is x2 is coordinate of point B, x1 is x coordinate of point A, y2 is y coordinate of point B, and y1 is y coordinate of point A. Using this formula, you can easily find the coordinate of this point P, which will divide this straight line AB in ratio m1 and m2. Now let us understand some of the important results from this section formula. Suppose a point P divides the straight line AB in the ratio k is to 1 or 1 is to k. Suppose I say this is the straight line AB and this point P is dividing this AB as 1 is to 2 or 1 is to 3 or 1 is to something. There 1 is fixed, 1 is to k. In that case, then the section formula is given by, in this case, m1, either m1 I can take it as 1 or m2 I can take it as 1. Remaining another m would be something different. Therefore, location of point P is given by k into x2 plus x1 divided by k plus 1, k into y2 plus y1 divided by k plus 1. Here m1 is equal to k and m2 is equal to 1. This is nothing but, this formula is derived from the previous formula, that is section formula. Wherever m1 is there, we have just put k, and wherever m2 was there, we have just put 1. In that case, you will get this formula. If m1 is 1 kept as 1 and m2 is kept as k, you will arrive with this formula. Special case, when p is at midpoint, in that case m1 is also 1 and m2 is also 1, means that point P is dividing this straight line AB in equal ratios, that is 1 is to 1, that is nothing but 50% 50%. In that case, above formula reduces to P x comma y is equal to just x1 plus x2 by 2 and y1 plus y2 by 2. So these three formulas play very important role. If any such problems are given, you can directly use this formula to solve that. Now let us take one example on this section formula. Find the coordinates of a point which divides the line segment joining the points 4, minus 3 and 8, 5 in the ratio 3 is to 1 internally. Means there is a point P present inside this straight line AB which divides this straight line AB in the ratio 3 is to 1. Means one side it is proportion 3 and another side it is just 1. Now we need to find the coordinate of that point P where it is exactly going to fall. Let us note down all the given data. I'll take first point as x1 y1, coordinates of first point as x1 y1, that is nothing but 4, minus 3, and coordinates of second point as x2 y2, that is taken as 8, 5. Here it has been given that it is dividing in the ratio 3 is to 1. Therefore m1 I'll take it as 3, m2 I'll take it as 1. Then the section formula is given by, we already know the section formula. Substituting all the values, these values in this formula, it looks something like this. When we try to simplify this, Px, y is going to come something like this. That is 8 into 3 is 24 plus 4 into 1 is 4, 3 plus 1 is 4, 5 into 3 is 15, minus 3 into 1 is minus 3 divided by 4. Therefore, coordinate of point P which divides these two, which divides the straight line connecting these two points internally in the ratio 3 is to 1 is nothing but 7, 3. Means its x coordinate is 7, y coordinate would be 3. Let us understand some of the examples on midpoint formula. Basically, what is midpoint formula? Special case of section formula when m1 and m2 are equal to 1. In the previous slides, we have seen special case where a point P divides straight line AB in the ratio 1 is to 1, or when a point P is exactly present at the middle of that straight line, that is called as midpoint. Then section formula derived in order to calculate coordinate of that midpoint is nothing but midpoint formula. Now using this midpoint formula, we are going to see some of the examples. If the points A 6,1, B 8,2, C 9,4 and D P, 3 are the vertices of a parallelogram taken in order, find the value of P. Suppose this is a parallelogram. His coordinates of this A, B, C and D are given. Now we want to find P value here, that is x coordinate of point D is not given, that we need to calculate. We know that diagonals of a parallelogram bisect each other. When these parallelograms, uh, when these diagonals are drawn in this manner, they bisect each other, means they divide each other in 1:1. This is going to be 50%, this is 50%, this is 50%, this is 50%. In that case, for this line, that is for line BD, this AC is dividing this BD as 1:1 here. Similarly, this BD is dividing this AC as 1:1. Let us see how we can find P here. Coordinates of midpoint of AC is equal to coordinates of midpoint of BD. We can see here this is one point that is dividing both these lines exactly in halves. Therefore, applying midpoint formula, x1 plus x2 by 2, that is for AC, x1 plus x2 by 2 and y1 plus y2 by 2. Similarly, for BD, x1 plus x2 by 2 and y1 plus y2 by 2. When we substitute all the formulas here, for AC here it is x1 is, I'll take it as 9, y1 x2 as 6, then y1 as 4, y2 as 1. This I have substituted. Similarly, for BD here, it is P plus 8, then 3 plus 2 divided by 2 here. Therefore, above formula reduces to, when I simplify this, it looks something like this. Here, equating x coordinate to x coordinate, we can see that y coordinate are already same. Therefore, 15 by 2 should be equal to P plus 8 by 2, so that this condition holds good. When I solve this, I get 2 get cancelled on both the sides. Therefore, P plus 8 is equal to 15 here. When I take this 8 on the other side, P is equal to 15 minus 8, that is going to be equal to 7. Therefore, if P value becomes 7, then these 4 points form a parallelogram. That is the conclusion we can draw from this question. Coming to the last concept of this chapter, that is area of triangle. We all know that formula for area of triangle is half base into height. But when coordinates of any 3 points are given, how to find area when area of that triangle when we connect those 3 points with a straight line? Let ABC be any triangle whose vertices are A, B and C, whose coordinates are x1, y1, x2, y2 and x3, y3 respectively. Then area of that triangle ABC is given by, this is the formula, that is 1 by 2 x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. How to remember this formula? Half we write usually as it is in the area of triangle formula. Then we can see here 1 2 3, then 2 3 1, then 3 1 2. This 1 2 3 is rotating in this clockwise direction, that one is shifting on the right, on the left hand side, 2 is taking one position, 3 is taking two's position. So you can see here 2 has shifted here in this next term, 3 has shifted to at the 2's location and 1 has shifted to 3's location. Now again 3 will come on 2's location, 1 will come on 2's location, 3's location and 2 will go on first 1 location. This is how you can remember this formula. Derivation of this formula is not there for the class 10 syllabus. You will learn it in the higher semesters, higher classes like class 11 or class 12. If I want to take an example for this, find the area of a triangle whose vertices are 1, -1, -4, -6 and -3, -5. The area of triangle formed by the vertices, these three, is given using the formula by something like this. Substituting all the values here, this is x1 y1, x2 y2, x3 y3. I'll substitute all the formula, and when I simplify this, I am going to get area of triangle something like this, that is 24 square units. Try to work out this example, how we got this simplified answer here. It is going to be very simple here. Coming to the last slide of this presentation, that is some more example on area of triangle. Here, find the value of k if the points a 2, 3, b 4, k and c 6, -3 are collinear. This is a question that is been frequently asked in the class 10 question papers previously. So if I consider these 3 points are collinear. What are collinear points? If 3 points exist on a same straight line, they are called as collinear points. We know that when 3 points are on the same straight line, area of that triangle would be equal to 0. Using that one information, we are going to solve this. We know that area of triangle formula is given something like this. When we substitute all the values here, area of triangle, when these 3 points are collinear, it should be equal to 0. Therefore, I equate this to 0. 1 by 2 I write as it is. X1 is 2 here. Inside the bracket, y2 is k minus y3 is -3. So I have written it in the bracket here, plus x2 is 4, inside the bracket y3 minus y1. y3 is -3, y1 is +3. Then x3 is 6 here, inside bracket y1 minus y2. y1 is 2, y1 is 3, y2 is k. When I simplify this, multiplying 2 inside here or taking this bracket out, that is minus into minus would be plus, 2 into k plus 3 here, plus 4 into minus 3 would give it -6, plus 6 into 3 minus k here. When I multiply this 6 inside, it would be 18 minus 6k. Now when I take this 2 inside this bracket, that is 2 into k is 2k, plus 2 into 3 is 6, and this is 6 into 4 is 24, plus into -24, plus 18 and minus 6k. 0 is equal to 2k, and when I add these all terms here, that would be -18 plus 18 minus 6k. Therefore 0 is equal to, when I simplify this, it should be -4k. Therefore k is equal to 0, which means if k value becomes 0 here, then these 3 points would be collinear. In that case, area of that triangle would be equal to 0. Hope you all understood this concept of coordinate geometry. Thank you for watching the video.